Okay, so when we have addition, subtraction of a matrix, they always have the same order. So it says there you have to have exactly the same order to be able to add them and subtract them. And the reason for that is because when you have two matrices and you're adding them together, you add the same position, the same element position. So you can see they get added together. So if I did this example down here, so first of all, I can see this has an order of a 2 by 3, and so does B, a 2 by 3. So if I'm going to add matrix A with B, so what I'm going to do is we're going to add them together, and you'll have the same order as the answer will be the same order, but of course it will be because they have to be the same, and you're going to add the same element spots. So because this one, I'm just going to write this out. So because that A has a 2 in its first spot, so here, so this 2 will get added with that 1, and then it'll become 3. And then we got this 3 with this 2, so it becomes 5, 3, 3, 2, and 3. Okay, so you're just adding the same spots. Be careful with the negatives. Make sure if you add if you've got adding a negative, you're actually taking it away. All right, with subtraction, the same deal. So the same spot is getting, say, subtracted, and that. So if I did this one, so if I said matrix A minus matrix B, I'm not going to write it out. I'm just going to write the answer. It's going to be a 2 by 3 again, but you're going to see it'll be, so obviously this 2 minus 1 will be there, 3 minus 2, 0 minus 3, 1 minus 2. Now be careful of this. This will be 4 minus a minus, and then you'll have 2 minus 1. So if I simplify that out, you'd get 1, 1, negative 3, negative 1. Now what when you have a minus and taking away a minus? It's going to become a plus. So that one became 6, and that one's 1. You can do them on your calculator as well. With things like this, it's quicker to do it in your head, and actually typing that in your calculator takes too long, and you don't have times an issue where you want to be really careful. Okay, so here's an example, an exam example. So it says, what is D? So if you look in the question, so this got added with D, and it got it equaled 11. So 1 plus what will equal 11? What would it be? 10, won't it? Because we know if I said 1 plus 10, that would equal 11. So that must be D. Okay, consider the 4 matrix expressions. How many of these expressions are defined? So defined means you can actually calculate it, and it's an expression because you're trying to add them together, and there's no equal sign. They're just saying if you add them together. Now we can only add them together if they have the same what? The same what? Order. So which ones have the same order? These ones have the same order, and that. So how many of these are defined? 2. 2 are defined. Okay. Okay, now we're talking about in this chapter C, we are talking about a scalar multiplication. So be really careful. Scalar multiplication is when you're multiplying by a number, yeah, outside the matrix. So that's what scalar multiplication is. So because we're also going to have matrix multiplied by another matrix. So when they say scalar multiplication, it just means we're putting a number out the front. And as you can see here in the notes, if you have a scalar number, so at that example up there, they've got a 7, you simply multiply every element inside the matrix by that 7. So whatever the scalar is. So if I have a look at here, when they asked me to find 3 times matrix A, it would be written like this. So you could write, I'm writing matrix A out there. Okay? And what you're doing is you're timesing every number in there by 3. 0 times 3.
Oh, that one's really hard.
Yeah. So you end up with, sorry, I've run out of room, but you'd end up with 6, 9, 0, 3, 12, and 6. Okay, so there's like that. Now, if you have obviously, as you said, those ones are pretty easy, so you could have done it in your head. With this one, you'd have 0.5 outside the matrix. Now, it could also be written as, a half. 0.5 could look like that. So a fraction outside is also a scalar. It's still a number. Okay? And you simply just times it by a half. So when you get a bit nastier ones, or, a nastier decimal, maybe it's 0.93 times, you can just do them on your calculator. So you just type in your scalar number, press times, and then put your matrix in. So this one would end up being 2, -2, -1, and 3. Okay? And obviously just that little point there, they're just saying whatever your order is to begin with, you'll have the same order to end with. So that C matrix is a 2 by 2, and my answer is still a 2 by 2. Okay, so let's have a look. Now, so here's an exam question, and it says you've got a matrix up there. What is this equal to? So what other matrix would end up producing that? So if you have a look at this one, if I multiplied that out, that would give me 12, 36, 0, and 24. Would you agree? Yeah, so that's another equivalent, isn't it? Yeah? If you check the other ones, they won't work. So say, for example, sorry, I'm just going to say this one, that would be 0, what's 12 times 24? What is it? 188? 288? 288? Something like that?
That's probably true. I don't know.
Yeah, 0 and 2, 144. Okay, so you can see none of the rest will work. So B works. Okay, let's have another quick look. Just to show you some exam questions that might bring up a scalar thing. So it says Eleanor imports 3 brands of olive oil. There they are, the C, L, and the O. The number of 1 litre bottles of these oils sold in January 2021 is in the matrix J below. What's the order of this matrix J? Good, a 3 by 1. Okay, Eleanor is expected that in February, the sales of all the brands of olive oils will increase by 5%. She multiplied the matrix J by a scalar value K. So that means K is just a number, yeah? And to get the new sales price, or the new sale numbers for February. So if you're going to increase something by 5%, so you're going to increase, what are you actually going to multiply? Yeah, you're going to multiply by 1.05. So when you increase it, it's 1 plus the percentage. What happens if you decrease it? It would be? Yeah, so if you want to write a little note there, if you decrease by a percentage, it'll be you're multiplying by 1 minus the percentage as decimal, yeah, and then say if we increase, we're going to do multiply by 1 plus the percentage as decimal. Okay, so the K value is just what we're going to multiply by, so that's what they actually want there, 1.05. Okay.